Assalamu alaikum wa rahmatullah. Inshallah, we will start our pre-calculus revision. We divided this revision into categories. So the first part is complex numbers. At first, we need to find I to the power 47. All what you need to do is take in 47 and divide it by 4, and you will see what the remainder is. This one, it should be 11.75. Remember that if you didn't have any decimal numbers, it's 1. If you have 0.25, it's I. 0.5, it's negative 1. 0.75, it's negative I. Okay, this is what will appear on your calculator. So 0.75, it will be negative I. Next one, I power 16, take 16 divided by 4, it will give you 4. So there is no remainder. If there is no remainder, it will be 1. If it was multiple of 4, it will be 1. Next one, I power 18, take 18 divided by 4, it will give you 4.5. 0.5, it's a negative 1. So you have to remember all of these. Next one, it's okay to use your calculator here, and if you want to do it with your mind, you will make 2 plus 8, it will give you 10. Negative 7, positive 1, it will give you negative 6i. And of course, when you use in your calculator, you must change it to complex mode. This one, it's okay also to use your calculator, and if you want to do it with your mind, you will make 5 minus 1, it will give you 4. 3 minus 1, it will give you 2. So it will be 4 plus 2i. Next one, this is a multiplication, and they are conjugate numbers, so you can multiply them in an easy way, first by first, second by second. So 8 times 8 equal to 64. Positive 4 times negative 4 will give you negative 16, and of course I power 2 is negative 1, we already know it, so it will change its sign. It will be 64 plus 16, which will give you 80. Next one, you can do this one with your calculator, and if you want to do it with your mind, it's very easy, inshallah. You will multiply by the conjugate of the denominator. So all what you need to do is multiplying by, what is the conjugate of 3 minus I? It's 3 plus I. 3 plus I. Of course, the denominator are two conjugate numbers, so 3 times 3 is 9, and 1 times 1 is 1. It should be negative, but I power 2 make it positive, so it will be plus 1. Up there in the numerator, you can use FOIL method. So first by first, 4 times 3 is 12. Outer sides, so 4 times I, it will give you 4i. And then inner sides, it will be 2i times 3, it will give you 6i. And then 2i times I, it will give you 2i squared, which is negative 2, because I squared is negative 1. Add the whole numbers, add the real numbers and complex numbers, of course. We can do it like this. 9 plus 1 is 10. So this one, 12 minus 2 is 10. And 4 plus 6, it's 10. So it should give you, if you simplify, 10 divided 10 is 1. And 10 divided 10 is 1i. So it will be I, 1 plus I. Of course, you can do it with your calculator, and don't forget to change your mode to complex mode. Next part is statistics. We need to get the mode. Okay, what is the mode? It's the most common value. If you noticed all of the numbers, you'll find number 9 is the most repeated value. It's repeated 2 times, and all of other values is repeated 1 time, so the mode is 9. If I asked you for the range, it's the greatest number minus the smallest number. So what is the greatest number here? It's a 24. And what is the smallest value here? It's a 3, so it will be 24 minus 3, it will give you 21. Next one, actually I'm sorry about these two questions. I have a little mistake when I wrote those. This one I'm asking you for the mean, and this one I'm asking you for the median. Let's solve it for this. Okay, if I ask you for the median, at first you need to arrange all of your values. So you will start arranging them ascendingly or descendingly, as you like. So it will be 3, 4, 5, 6, 7, 9. and then you will start crossing the values so that you can find the number in the middle, the median number in the middle. So I can say 3 was 9, 4 was 7, 5 was 6, so the number in the middle is 6, so I'll choose 6 here. Okay, what about the mean? To get the mean, all of you need to do is add in all of your values, so it will be 3 plus 8 plus 4 plus 9 plus 12 plus 11 plus 3 plus 6, and after adding all of them you will divide by their number. So 1 2 3 4 5 6 7 8, they are 8 values. Calculate all of this. This one 11 15 24 36 47 50 56. 56 divided by 8 is equal to 7, so the answer will be 7. Next part, finding the value of the function. Okay, actually this part is very easy. All what you need to do is plug in your number. So if I need to get f of 2, when I'm using this one, f of x is equal to 2x squared plus 2x minus 5. Okay, to get f of 2, you will just replace x with 2. So it will be 2 open brackets here for x plus 2 open another bracket minus 5. And I need to plug in 2, so it will be 2 in place of these brackets. And you can solve it right now. It will be 2 squared 4 times 2 8 plus 4 12 minus 5, it will give you 7. So the answer should be 7. 4 8 12 7. Okay, next one is the same. If you need to get f of 3, all what you need to do is make in a space for x so that you can plug in your numbers. So put 7 here. 7 plus 3, 350 minus 7, so it will be 343. 343, yes. Minus 4, it will be 339. Okay, next part. Okay, this is a piecewise function. It's similar. It's a similar idea, but you need to consider first which part you will plug in your numbers in. So if you need f of 5, at first you will search where's 5 is. Is 5 is bigger than negative 3 or smaller than or equal to negative 3? No, it's bigger than negative 3. So I'll cancel this part and only plug in my number in this part. So to get f of 5, it will be 2 times 5, which is equal to 10. Okay, next one is the same. You need to get f of 1. At first, decide where is 1 in your piecewise function. These numbers are bigger than 1, and these numbers are smaller than 1 or equal to 1. So I'll plug in my number in this part. Actually, this part is a constant function, so it will be the same on all of its domains, so it will be 5. Next, okay, this one I need to write it in using interval notation. How you will do it? Okay, you remember interval notation, you was using square brackets or rounded brackets, something like this, and you need two numbers. You will start with a smaller number here and the bigger number here with a greater number here. Okay, we actually have it. So we have 3, we have 7, but how to decide which bracket I will use? This one, I'm starting after 3, I'm not having 3, so it will be a rounded bracket. There is no line under the inequality sign. But this one, uh, it's smaller than or equal to 7. I have this line here, so it will be square brackets. So it will be like this, half open interval, 3 and 7. This one, I'm only having one number, so remember the other thing is the other quantity, it will be infinity or negative infinity, and you have to decide which one of them you will use. Actually my numbers is getting bigger than negative 1, getting bigger than negative 1, so it goes to infinity. So I will start from the number and goes to infinity. So I'll start with negative 1 and goes to infinity. Of course infinity all the time, it's round brackets. Okay. About negative 1, do we use round bracket or square bracket? Okay, we have this line which is equal to negative 1. We're starting from negative 1, so it will be square bracket. Next one, we have only one number, so we'll go into negative infinity or infinity. Our numbers are smaller than 4, are getting smaller than 4 all the time, so it's going to negative infinity. If it goes to negative infinity, I will start with negative infinity and then the number, not the inverse. Okay, because negative infinity is smaller than this number. And this one is round bracket. What about 4? We don't have the equal sign, so it will be square bracket. This one is very easy. You will start with a smaller number, not 4, it's 1 and then 4. Then both of them have equal sign, it will be square brackets. Okay, next part, types of discontinuity. Actually, you have 3 types of discontinuity. At first, this curve, it's continuous. If I cut it in 2 parts, I'm sorry. If I cut it in 2 parts like this one is discontinuous. We have this type of discontinuity. This one, the point is above each other. It's like you want to jump from one point to continue your curve or your function. This one is called jump discontinuity. What about this one? We have only one point removed from the line, from the curve, from the graph. One point only removed, it's removable discontinuity. We could find the point up or down, or we even couldn't find it at all. But this one, if you have one point removed from your graph, this one is called removable discontinuity. And the last one, if you have your curve going to infinity or negative infinity, of course you have your asymptote as a dashed line. This one is called infinite discontinuity. Infinite discontinuity. So you have 3 types of discontinuity. The 3 types are jump and removable and infinite. Okay, these are the 3 types of discontinuity. About the graph, is asking for only one type of discontinuity, it's jump. Okay, we have a discontinuity here at x equal to -2, and we have a discontinuity here at discontinuous part here at x is equal to 4. X is equal to 4, actually it's an infinite discontinuity, but this one, it's a jump discontinuity because the point is above each other, so to move from one part to another part you have to jump. So I will tell him the answer will be x equal to -2. This is your answer. X is equal to -2. Okay, next. I'm sorry, just 1 second. Yes. Next part, I need infinite discontinuity. Okay, where is infinite discontinuity? We have our asymptote here. It's at -1 exactly, so at x equal to -1, we have infinite discontinuity. One of parts is going to infinity, the other one is going to negative infinity, so infinite discontinuity, it would be at x equal to -1. Okay, next. This one we need removable discontinuity, so remember it's just one point removed. Okay, one point removed, we have it here at x equal to 4. Look to our graph, it's going like this, and then I removed one point and continue my graph. So at x is equal to 4, we have a removable discontinuity. Next one. Okay, we need an absolute maximum. Absolute maximum. Okay, absolute maximum is the highest point on all of your graph. The highest point is this one. So where is this one? This point is located at? It's at x is equal to 2. Okay, we need an absolute minimum. It's the same, the lowest point in all of your graph. It will be this point at x is equal to -2. Okay, relative maximum. Okay, about relative maximum, it's not the highest point in all of your graph. Actually, your graph is going to infinity. It won't stop. Okay, but relative maximum, it's a high point, higher than its neighbors. You can think about it like this. If your country having a mountain, for example, and it's very high, it's a mountain, it's very high, so it's a maximum point, you can find it in all of your country. But is it the highest mountain ever in all of the world? No, of course. You can say the highest mountain in all of the world is something, for us in math, it's called absolute maximum. But if it was the highest point in your country or in your city or something like this, it's relative maximum. So actually the relative maximum here is this point, because it's higher than its neighbor. It's the highest point here. So this point is a relative maximum. It's not the highest point in all of the graph. We have this point higher than this one. This point is higher than this one, and it's going to infinity. But it's higher than its neighbors. Okay, it's like the highest point in its interval. Like from here to here, it's the highest point. So it will be at x is equal to 0. Next one. Okay, relative minimum is the same. It's not the lowest point in all of your graph, but it's the lowest point in its interval or its neighbors. It will be this one. Okay, also at x equal to 0. Next one. Okay, we need to get x-intercepts, zeros, y-intercepts, all of this. We need to get x-intercepts. What's the meaning of x-intercepts? Where is your graph cutting the x-axis? Okay, we're cutting the x-axis here and here. So where exactly? I'm sorry, x-intercepts, yes, we're cutting our x-axis here and here and here. Okay, this one is a little bit difficult for you. I think the graph is messed up here, but I will give you the idea. If you need to get x-intercepts, okay, you need to get these points, all of these points. If you have your equation, you can use your calculator and make it like this. Solve for x, negative x power 4 plus 4x power 2 minus 1 is equal to 0, and you will solve it. You will choose your x values a little bit greater than smaller than negative 2, like negative 2.1 or something, and then negative 1, and then 1, and then 2 point something. You can do it like this and you will get the actual values. But right now, if I give you a graph, okay, let's say this part is not here, this part is not here, okay, and we need to estimate where is the x-intercepts. Okay, x-intercepts is this point and this point. We can estimate it at x is equal to negative 2 and at x is equal to 2. And please don't take care about this equation because it's not the actual values. So where's x-intercepts? Where's the graph is cut in your x-axis? It will be at x equal to negative 2 and x equal to 2. Okay, if I told you where's the point of x-intercepts, you have to write it as an order pair. Okay, x is equal to negative 2, x is equal to 2, about y it's 0. So when you need to get x-intercepts, you put y is equal to 0. So this is your solution right now. Another example for this part. If you have your graph like this, okay, and your function is going like this, and I told you where's your x-intercept, you will search for this point and this point. If this one was at negative 3 and this one was at 3, you will tell me the x-intercepts is negative 3 and 0, 3 and 0. This is about this question, okay. Next one, I'm asking you for y-intercepts. Y-intercepts, okay, y-intercepts, where's your graph is cut in y-axis? Actually, if you estimate it, it's cutting the y-axis here at this point. Okay, you need to locate this point. What is the coordinates of this point? So speaking about y, it's y is equal to negative 4. But if I told you write it in an order pair, and this is what I am asking you for, you will write y equal to negative 4 about x, it will be 0. Okay, so negative 0 and negative 4, 0 and negative 4. This is the y-intercept. Okay, next one. If I asked you for the zeros, it's the same as x-intercepts. Okay, so if I told you, can you estimate the zeros of this function, you will search for x-intercepts, this point and this point. It's at 2 and 8. So actually this one is written as a set, so it will be like this, 2 and 8. Okay, if you wanted to write it like a set and with 2 order pairs, it will be like this, 2 and 0, 8 and 0, and you can write it like this because it's zeros. Okay, next one. Okay, I need to figure out what is the domain of our function. The domain is asking you for the x values, not the x-intercepts, the x values. Okay, we have an arrow here. It means goes all of the way to the left and all of the way up. So speaking about x values, we care about this one, all of the way to the left. The same here, so it will be going all of the way up and all of the way to the right side. So actually we have all of the domain, all of real numbers, so it will be negative infinity to infinity. This is our domain because I'm speaking about x values right now, or you can say it's r. Next one, the range. Okay, when we're speaking about the range, we will searching for y values. What is the lowest point and what is the highest point? If we're searching for the lowest point, this one, and it's at -2. And this one is not a hole, it's a line like this, so it will start from -2 like this, and it goes all of the way up from the side and from the side, so it goes all of the way up, so to infinity. So the range from -2 to infinity. Next one, can you find the domain of this one? Okay, we have a rational function. We accepted this. Rational function, it's like a fraction. You can write any number in the numerator and the denominator, but you cannot write 0 in the denominator. So when this one is equal to 0, it's at -7. Okay, at -7. So the domain will be R, all of real numbers except -7. This is your answer. Okay, all of real numbers except -7. Next one. Okay, we need to graph using the parent function. Of course, you know, you have to remember what is the shape of this function. Radical. It's the same as the radical. If you want to draw a radical, it's the same as a radical. Okay, but we have a little transformation here. It's a translation. So -7 plus 5. Let's get the center point. We will change the sign of the number beside x. Will be +7, and this one will be the same. So it will be 7 and 5. 7 and go up to 5. This is your vertex or center point, as you like, and draw your graph. This is the solution. Okay, next one. The same, we have a transformation here. This one is quadratic, so x part 2, it's drawn like this, smile face. And we have a translation here. So what is the vertex? We have it at -2 and 4, because we invert the sign of the number beside x, so it will be -2 and 4. -2 and 4, this is our vertex, and draw your happy face. Okay, this is how you will do it. Next one, cubic. So remember how to draw cubic function. It's like this. Okay, and our center point here is 1 and 4 and -5. 1 and -5. Invert the sign of the number beside x and keep the sign with the number of y. So it will be 1 and -5. It will be here. So it will be here. To draw it, just do it like this. Okay. Next one, how to determine the odd and even function. Okay, we will get f of -1. F of -x. Okay, so it will be 1 over -x squared, and then you will simplify. Power 2 even power, it will cancel the negative sign, so go back again to x squared. So from f of -x, we get back again to f of x. So both of them are equal, so this function is even. Okay, next one, it is the same. Let's get f of -x. It will be -x squared plus 7, and one more time, square cancels the negative sign, so it will be x squared plus 7. We got back again to our real function, which is original function, which is f of x. So this one also is even. If you got a different expression here, you will take negative as a common value, as a common factor, as a common factor, and then you will compare this part with the original function. If it was the same, it will be odd. If it's not the same, so it will be neither even nor odd. Okay. Next one, finding the composition of two functions. It's very easy. This one we need to get f circle g. So it's like if you have a number here, you will plug it in g and then get the answer, plug it in f. But actually we don't have a number, so only plug g into f. So prepare f, f circle g of x. Let's start with f and prepare for this. This is f5x minus 9, so 5, open a big bracket, minus 9. Inside this bracket, you will plug g, which is 7x. And then what you will do is just simplifying it. So 5 times 7, it will be 35 x minus 9, and here's your solution. Okay, wipe out next part. We need f plus g. uh, Actually, you will add the two functions. This is all what you need to do. So you will get f, which is 5x minus 9, and then add it to g, which is 7x. Next step is just simplifying them. You can add 5 to 7 because both of them are having a coefficient of x. So it will be 12x minus 9, and here is your solution. Next part, the same. We need to get f circle g of x. So f circle g of x. Let's start preparing f. This is f, so it will be 2. Make a big bracket, power 2 plus 1. Plug in your g here, which is 4x, and then simplify this one first. Let's get the square first on these two, so it will be 16 x squared plus 1, and then multiply these two numbers. It will be 32 x squared plus 1. Okay, about the second part, we need to get f minus g of x. You have to be careful when you're dealing with a negative sign. We will start with f 2x squared plus 1 minus an open bracket. Okay, this is 4x, because if you don't have a monomial here, binomial or trinomial or polynomial, something like this, you have to distribute your negative sign, but actually right now we don't have to. So it will be 2x squared and negative 4x. We will just arrange them and then plus 1, and this is your solution. Next, we need to get the inverse function of this one. Okay, actually you need to replace y for x. Remember, inverse function are they have a reflection about y is equal to x. Okay, so this is y and this is x. You just have to replace them. So x is equal to y plus 3, and then separate y. It will be 2y is equal to x minus 3, because we're moving this one to the other side with negative sign, and then divide both sides by 2. So it will give you y is equal to x minus 3 over 2, and this is your solution. This is the inverse function. Okay, next one, it's the same. We need to get the inverse function for this one. This is y, this is x. Let's replace them. So it will be x for y plus 5. This one we will do a cross multiplication, so it will be x times y plus 5, and 1 times 4 is 4. If you need to distribute x right now, you can do it, and you can keep it like the same. I can divide by x in both sides, so this one is divided by x and this one is divided by x, so it will be y plus 5 is equal to 4 over x, and then you remove this one to the other side with a negative sign, so it will be y is equal to 4 over x minus 5. This is your solution, and if you distributed x, you will have something like this, and it's okay also. It will be 4 minus 5x over x. Both of them are okay for me. Okay, next one. Alhamdulillah, we have finished. If you have any question, please send it to me. Thank you.